Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 1, Probability, brought to you by Vitan Sir. Let us continue with the exercise 1.2, and this will be the last tutorial for this exercise. This is the third tutorial. You can check out the previous tutorials on the screen here. Question number 13. Four couples, husband and wife, attend a party. Two persons are randomly selected from these eight persons, and then we have to find the probability that the selected persons are. Now, four couples, that means 4 to the 8 people are there, and we are supposed to select two people. So, before we move forward towards the question, let us find out the total outcomes here. So the total outcomes will be selecting two people out of 8, that is 8C2. So 8 into 7 upon 2 into 1, answer will be 28. So the total outcomes N are 28. Moving on to the first question, the selected two persons are husband and wife. Now when we talk about husband and wife, we can also say that they are a couple. Okay, so when a couple we are selecting, then we already have four options. So out of four couple, we will be selecting one couple. Out of four pairs of husband and wife, we will be selecting one pair. So the combination here for the favorable outcome will be 4C1, that is 4. Four pairs selecting one couple, so 4, and the probability will be 4 upon 28 to be simplified into 1 upon 7. The second question is that the selected people are men and women. Now, as we know that there are 4 men and 4 women. So, from each we will be selecting one. That is 4C1 into 4C1. That will be 4 4s are 16. So, the favorable outcomes for selecting one man and one woman are 16. The probability will be 16 upon 28 to be simplified into 4 upon 7. Moving on to the third sub question, that one man and one woman who are not husband and wife. That means we are selecting one man and one woman just like last time. But among them, we should not have a husband and wife. So what we are going to do, we will suppose that out of four men, we select one. Next, out of the four women, we are supposed to select one woman, but out of the four, one will be the wife of the first selected man, which we cannot actually select. So when we select one man out of the four men, we only have the option of selecting one woman out of the three women. Why? Because the fourth woman is the wife of the man which we selected. So our options are out of four men selecting one man, and out of three women selecting one woman. Okay, so combination will be 4C1 into 3C1, that is 4 into 3, 12. The probability will be m upon n, that is 12 upon 28 is equal to 3 upon 7, to be simplified. Next question, 14th one. 8 employees are employed in a factory and 3 of them are excellent in efficiency, whereas the rest of them are moderate in efficiency. Two workers are randomly selected out of these 8 workers. Then we have to find the probability, but before that we have to find the total outcomes. So we are selecting 2 workers out of 8 workers, that will make it 8C2, that is 8 into 7 divided by 2 into 1, that is 28 total outcomes. The first question now is what the workers have excellent efficiency. Now we know that the total efficient workers are 3 and we are supposed to select 2 out of them. So combination will be 3C2, selecting 2 workers out of 3. So 3C2 will be just 3. In case you don't know how these combinations work, you can just refer to my 11th video of the combinations and permutations. Probability here will be 3 upon 28. favorable outcomes upon total outcomes. Second sub question, both the workers have moderate efficiency. Now we know that out of 8 workers, 3 had excellent efficiency, and that simply means that 5 had the moderate efficiency, of which we are selecting 2. So the combinations here will be 5C2, that is 5 into 4 divided by 2 into 1, that is 10. So the total favorable outcomes are 10, and the probability here will be 10 upon 28, that is equal to 5 upon 14. So the probability is 5 upon 14. Third sub question, 1 is excellent and 1 is moderate. That means out of the 3 excellent workers, 1 is to be selected, and out of 5 moderate workers, again 1 is to be selected. So the combinations here will be 1 out of 3 and 1 out of 5, that is 3C1 into 5C1, that is 3 into 5, 15. And the probability is 15 upon 28, and there is no further simplification for this. So that was the end of the question. Moving on to the question number 15, 2 cards are drawn from a well shuffled pack of 52 cards. Of course, when we are selecting 2 cards from 52 cards, the total number of outcomes we will face is 52C2. That is 52 into 51 divided by 2 into 1, that is 1326. So total number of outcomes are 1326. First question, sub question, both the cards are of different colors. Both the cards have different colors. Now I have already explained how these cards work, and in case you don't remember, just refer to my video which I have suggested at the top right corner of the screen to watch how those cards are explained in them. So both the cards are of different colors. That means one is red and one is black. Now we know that 26 red cards are there and 26 black cards are there. So one card from each will make it 26C1 multiplied by 26C1. That is 26 into 26, 676. Putting it into the probability will be 676 divided by 1326, and simplification will make it 26 upon 51. Simplification is something which you should learn in your elementary standards. So just apply that concept here. Second sub question is both the cards are face cards. Now again I have told you to refer to that particular video. So there are total of 12 face cards, and out of them we are supposed to select 2. So that will make it 12C2, that is 12 into 11 upon 2 into 1, that is 66 options. Those are favorable. Putting it into the formula, 66 upon 1326 simplified as 11 upon 221. The third sub question, one of the 2 is king. Now the question here is that one of the 2 is king. That means one card is king, then the other could be from the remaining 48 cards. Now how come it is 48? There are 4 kings in a pack of 52 cards. So when we select one king, the remaining kings are removed from the 52 cards and the remaining cards are 48. So one king from 4 kings and one card from 48 cards. So this will be something like the second is from remaining, and therefore favorable outcomes, one king out of 4 cards and one card out of remaining 48 cards. 4 into 48, that is 192, and the probability will be 192 upon 1326. Simplified is 32 upon 221. So that was the question number 15. Moving on towards question number 16. 3 bulbs are defective in a box of 10 bulbs. 2 bulbs are randomly selected from this box. These bulbs are fixed in 2 bulb holders in a room. Find the probability that room will be lighted after turning on the electricity. Okay, so this is a question where we have to use our brains a bit rather than just using the knowledge which we have mugged up till now. But before that, let me clarify something. The total number of bulbs are 10, of which 3 bulbs are defective and that means the remaining 7 bulbs are non-defective. Now, if we want the room to be lighted, we must need a non-defective bulb, and before that, the total outcomes here that we are using 2 bulbs out of 10 is 10C2, that would be 45. Now, to meet the requirement that the room must be lighted, out of the 2 bulbs, at least one or both of the bulbs must be in working conditions. Okay, if we have put 2 bulbs and both of them are not working, then obviously room will not be lighted. So to light the room, either one or both the bulbs must be working. We will follow along with the same concept to calculate the probability for this question. That means writing down in the words one good and one defective bulb is the first option, or the second option that both are good bulbs. So we right now have two options for calculating the probability of. The first option is one good and one defective, or both are good. But when we are talking about probability, we will just add both of these options. Now if I talk about one good and one defective bulb, then one good will be out of the 7 good bulbs and one defective bulb will be out of the 3 defective bulbs. So it will be 7C1 into 3C1, that is 7 3s are 21 options. So there are 21 options where one is a good bulb and one is a defective bulb, or both are good bulbs. That means both the bulbs belong to the category of 7 good bulbs. The outcomes will be 7C2, that is 7 into 6 upon 2 into 1, that is 21 outcomes again. So when we combine both of these outcomes, we will just add them up. That would be the total favorable outcomes. M is equal to 42. Remember, whenever the word or is used in between the events, we add both of those events, because we can't combine these events with multiplication, because these events can't happen simultaneously, rather one or the other can happen. So right now the total favorable outcomes are 42. When we put it into our formula of probability, it becomes 42 upon 45, and dividing the numerator and denominator with 3, we get 14 upon 15. So the probability that the room will be lighted is 14 out of 15 times. Quite a huge probability if you ask me. Moving on to the question number 17. For two events A and B in the sample space of a random experiment, PA is 0.6, PB is 0.5, and A intersection B is 0.15. We will find out events one by one. The first question is PA dash. Now A dash basically means the complementary events, and for solving this kind of sums, you will need to remember the important forms which I have explained in a particular tutorial, which you can see at the top of this screen if you want to check them out. Using those results, we will be solving this question here. So PA dash is the complementary event of PA. So to calculate it, we will deduct PA from 1. So the answer here will be 1 minus PA, that is 1 minus 0.6 will be 0.4. Second question here is PB minus A. You will have to refer to the same forms which I just told you guys. B minus A is the difference event, and the formula is probability B minus A intersection B, that is 0.5 minus 0.15 is 0.35. Third question is A intersection B dash. The formula for A intersection B dash is probability A minus probability A intersection B, that is 0.6 minus 0.15, which is 0.45. The fourth question is A dash intersection B dash. The formula for this is A union B dash, which converts into 1 minus A union B, that is 1 minus 0.95 is equal to 0.05. Now if you are wondering where did I get this 0.95 from, so it is A union B formula. I will explain you guys here. That is A plus B minus A intersection B, that will be 0.6 plus 0.5 minus 0.15, that is 0.95. This value I used in the above equation. The fifth sub question is A dash intersection B dash union B dash, my mistake. So it becomes A intersection B whole dash, that is 1 minus A intersection B, that is 1 minus 0.15, that is 0.85. So whenever dash is there, we just have to reverse the values or deduct them from 1 minus. Okay, so if we have A union B whole dash, it becomes 1 minus A union B. If we have A intersection B whole dash, it becomes 1 minus A intersection B. The most important point here is that you need to remember those forms which I just mentioned. In the case you have not, just refer back to that video and you will know which forms they were. This is the last question for the exercise 1.2, which has been going on since almost 3 tutorials now. We have PA dash, which is equal to 2 times PB dash, which is again equal to 3 times PA intersection B, which is equal to 0.6. That means PA dash is 0.6, 2 times B dash is also 0.6, and 3 times PA intersection B is also 0.6. Before we find out what we are supposed to, let us just simplify these values. That is 2 times PB dash is simplified as only B dash, the answer will be 0.3, and A intersection B answer is 0.2. I have just divided them with the values. Next, I am supposed to calculate difference events A minus B and B minus A. But for that, I will be requiring the probability of PA and PB, which I don't have right now. Rather, I have their complementary events A dash and B dash. So using these events, I will calculate the values of probability A and probability B. So probability A is 1 minus PA dash, that will be 1 minus 0.6, that is 0.4. Similarly, PB is 1 minus PB dash, that is 1 minus 0.3, that is 0.7. Now using these values, I can actually calculate my difference events. The formula for A minus B is A minus A intersection B. So that would be 0.4 minus 0.2. Okay, that is 0.2. Similarly, B minus A is probability B minus probability A intersection B. So that would be 0.7 minus 0.2, that would be 0.5. Okay, I hope you guys understood this exercise properly. If you have any doubts, you can just replay all the 3 tutorials of the exercise, or you can contact me on the number given in the end of this video. Okay, welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.